Due to valence electrons and obeying the octet rule,
Elements have a normal way of bonding.
For our class, we are going to say the following.
Hydrogen always has one bond.
Carbon always has 4 bonds.
Most of the time, nitrogen has 3 bonds and 1 lone pair.
most of the time, oxygen has 2 lone pairs and 2 bonds.
Fluorine has one bond and 3 lone pairs. Also note, chlorine, bromine, and iodine also bond this way.
Notice that the octet rule is always obeyed. 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, and 2, 4, 6, 8. Now let's take a look at how we would draw a compound such as C4H10. Well, we know that hydrogen always can only have 1 bond, so it has to be on the outside. So we'll start off by connecting all of our C's. We also know that carbon has to have 4 bonds, so I'm going to go ahead and give it 4 bonds. And then we're going to see how many empty spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 empty spaces, 10 hydrogens, a perfect match. And that is C4H10, which is also butane. Now let's take a look at C4H8, very similar compound. Again, hydrogens have to be on the outside, so we know C's are in the middle. I'm going to give every C 4 bonds again, and count the empty spaces. Again, it's going to be 10 empty spaces, but now we're going to have 8 H's. So what I'm going to do, 1, 2, 3, 4, 5, 6, 7, 8. You can't leave this here because it can't be bonded to nothing. So I'm going to go ahead and erase this. Now the problem with this structure is these 2 carbons do not have 4 bonds, whereas this one does. 1, 2, 3, 4. This one only has 1, 2, 3. This one has 1, 2, 3. So what you do is you go ahead and give it a double bond, and then now it is correct. Every carbon has 4 bonds, every hydrogen has 1. Let's take a look at some nitrogen compounds. Again, we know that most of the time, nitrogen wants 3 bonds with 1 lone pair. So as soon as I see this, I say 3 bonds, 3 hydrogens, that makes a perfect match. So I know it's going to be like this. NH3, and that's common household ammonia. But now we look at this, and we know the rule is going to be broken because we have 4, hydrogen has to be on the outside, and whenever you see a charge, that usually means these rules are broken. Alright, and again, because hydrogen has to be on the outside, it has to be like this. There's no other choice. And that is the rule. And also, again, the octet rule. 2, 4, 6, 8. 2, 4, 6, 8. Now we take a look at NH2. Again, hydrogen has to be on the outside. So it has to be like that. But now the question is, am I done? How do you know if you're done? It's the octet rule. 2, 4, that's not good enough. 5, 6, 7, 8. And now you are done.
H2O is going to look something like this, with the 2 hydrogen bonds on either side. Now the octet rule shows we have 2, 4, 6, 8, and now you're done. For H3O, it has a charge, so the bond is going to change. You're going to have oxygen here, with 3 bonds to hydrogen, and then 2, 4, 6, 8. Now you're done. And now for OH, you just have the O with 1 hydrogen bond, and that's only 2, so 4, 6, 8. Perfect.
Okay, F2, you have to bond your 2 F's. And then because these 2 only have, these share 2 electrons, you have to add 6 to both. That's it.
Alright, for O2, O bonds to O. And since there's no charge, it wants 2 bonds, so you give it another bond, and then you have to give it 8, so you add your electrons in to give it 8 for each one.